Number 36. It says, in a Powerball lottery, 5 numbers between 1 and 12 exclusive are drawn. These are the winning numbers. And also, the word inclusive means numbers between 1 and 12, including 1 and including 12, are considered. If it said exclusive, then it would exclude the number 1 and the number 12. These are the winning numbers. How many different selections are possible? Assume that the order in which the numbers are drawn is not important. So we're drawing 5 numbers between 1 and 12, including 1 and including 12. It wants us to find how many different winning orders are possible if the order is not important. When the order is not important, as what we're going to see for questions 36, 37, and 38, we're going to be using a combination of n objects, and you're choosing r of them. So a combination of n objects and choosing r is going to equal to n factorial divided by n minus r in parentheses factorial times r factorial. In this case, we cannot use the fundamental counting principle like we was able to when we had a permutation. So, in our case, because we have 12 numbers, which includes 1 and includes 12, the n is 12. And because I'm choosing 5 numbers with regard to order, r is going to be 5. So setting that up for number 36 in the combination formula, that is going to be the combination of 12 balls, choosing 5 when the order does not matter. That's going to equal to 12 factorial divided by 12 minus 5 in parentheses factorial times 5 factorial. In my parentheses, 12 minus 5 is 7. So 12 factorial divided by 7 factorial times 5 factorial. Expand the larger one. Expand the top to the larger factorial to simplify that, and then expand the smaller one. So the larger factorial in my denominator is 7 factorial. So we're going to expand my 12 factorial until I reach 7 factorial. 12 times 11 times 10 times 9, come on, pen, work, times 8 times 7 factorial. And that's going to be divided by 7 factorial, which means those two will simplify each other out. And then you're going to expand the smaller one, which is 5 times 4 times 3 times 2 and times 1. And that is going to be 120 in my denominator when I multiply that. We're going to multiply the numerator now. 12 times 11 times 10 times 9 times 8. 95,040. Let's divide that. 95,040 divided by 120 equals 792. So the answer to number 36 is 792. You can also do this using the TI-83 or TI-84 calculator. We want to find the combination of 12 and 5. So type in the first number, 12. Go to math. Use your arrow on your calculator to scroll over to PRB. Combination is going to be the number 3. After that, you're going to put in your second number, which is the number 5. Hit enter, and the answer is going to be 792. So that is how we approach question number 36. We're going to do number 37 and 38 on the whiteboard, and then we'll go back to the calculator as need be. Number 37. It says, a teacher has 20 boys and 10 girls in her class. In how many ways can she select 6 of the children to play if she must select 3 boys and 3 girls? Okay. Let's make that a little bit more even. So we know there's a total of 20 boys in the class and 10 girls. And the teacher must select 6 of the children to play. I think this is a band. Oh, to be in a play, excuse me. To be in a play, and she must choose 3 boys and 3 girls. Now, she's choosing 3 boys from 20. Out of 20 boys in total, she's choosing 3. When a boy is chosen, that boy is no longer able to be picked, which means once I choose a boy, I'll have 19 boys left for me to pick from to fill the remaining spots. It also does not matter the order in which the boys are selected or which 3 boys are selected from 20. Because the order does not matter in how I select my boys, and it does not matter which 3 boys that I'm choosing to be in the play from 20, that is going to be a combination of having 20 boys, and we are choosing 3 of them to be in the play. When it comes to the fundamental counting principle, and especially when it comes to a combination or a permutation, the word "and" indicates multiplication. There are 10 girls in my class. I must choose 3. It doesn't matter which 3 girls I choose from 10, nor in the order on how I choose my 3 girls from 10. Therefore, to represent how many ways I can choose a number of girls, that's going to be the combination of 10 girls in the class, and I am choosing 3 for my play. What we're going to do is we're going to calculate the combinations using the TI-84 calculator. So that's going to be 20. Go to math, over to PRB, choose combination. That is going to be 3. That is going to be 1,140. And you're going to multiply that with the combination of 10 and 3. I think that might be 120. I could be wrong. So type in 10. Go to math. It's still on PRB. You're going to put in 3. That equals to 120. So we can multiply 1,140 with 120. And that is going to equal to, got to scroll down a little bit, 136,800 ways. And that is it to question number 37. So I hope number 36 made sense so far and number 37 makes sense. We're now going to calculate question number 38. Number 38 says, in how many ways can a person select 4 books, 2 CDs, and 1 DVD from 10 books, 20 CDs, and 5 DVDs. We're choosing 4 books from a total of 10 books. It doesn't matter which 4 books that we choose as long as we choose 4 books. I'm going to close that out in this case. I'm not going to use the whiteboard for this one. So, out of 10 books, I am choosing 4, and the order does not matter in how I choose my books, and it doesn't matter if I choose the books first as long as I choose 4 books. The word "and" in this case, when it comes to my selection choice, means multiplication. So I'm going to multiply with the next category because I am choosing 2 CDs from a total of 20 CDs. It doesn't matter which 2 CDs that I choose as long as I choose 2, and the order in which I select my CDs is irrelevant. Therefore, that is going to be the combination of having 20 CDs in total, and I am choosing 2. And that is going to be multiplied with the combination of me having 5 DVDs in total, and I am choosing 1 DVD in this case. So we're going to calculate the combinations, and then we're going to multiply them. Multiply the numbers, I mean. So let's split my screen. Usually I don't show how I split my screen, but I'll show it in this case. Let's clear this calculator. So let's do it. Actually, let's do it all at one time. 10 combination 4 times, that's going to be 20 combination 2. And that's going to be times 5 combination 1. And that's going to equal to 199,500 ways. All right, guys, that is it. I hope questions 36, 37, and 38 make sense, whether from calculating by hand or using a TI-83/84 calculator. I'll see you soon. Take care.